Hello students, welcome to E-Pathasala. Myself M. Saravanan, working as Assistant Professor at Kumarur College of Technology. Today we are going to discuss about the module Functional Finishes. Introduction about the module. Increasing concern over damage caused by the exposures to microbes, chemicals, pesticides, UV light and pollutants in the last few years has heightened the demand for protective garments. Clothing today is expected to be waterproof, flame resistant, self-cleaning, insect repellent and antimicrobial to protect the human beings from various infections. Even UV light, chemical and biological agents be warmer in the winter and cooler in summer, at the same time being light and less bulky are the current expectations from the users. Value addition in manufacturing is the sum of gross output less the value of intermediate inputs used in production. These are achieved by the chemical finishes, assumes significance because the value addition is realized through multifunctional finishing treatments imparting the desirable properties. They are termed as specialty finishes and is usually in the form of functional, play a significant role in the value addition of textile products termed as technical textiles. The technical textile is made of synthetic fibers like polyester, nylon, acrylic to demand the functional finishes, but the cotton emerges as the most popular fabric. Some new finishing techniques have been given to the cotton exclusively. Cotton is amazingly versatile, thus it's used alone or blended to comfortable aspect. Humidity either in hot or cold, cotton breathes. At hot, cotton perspires. It absorbs moisture and releases it on the fabric during the cold weather. If the fabric remains dry, the fibers retain body heat, especially napped fabric. Cotton absorbs to 27 times its weight of water. It has a comfortable soft hand, takes dye easily, conducts heat well, resists the pilling. The objectives of the module elaborates the following objectives and it incorporates the importance of functional finishes for the textile materials. Objective number 1, functional finishing chemicals used to develop multiple performance of textile materials with different requirements are detailed in this module. Conventional chemicals used for those kind of functional finish fabrics are also discussed. Objective number 3, importance and characteristics of various functional finishes and their response to different environments, sometimes hazards, are also detailed in this module. Easy care finish. It is such kind of a functional finish. The cotton garments ensures maximum comfort because of its humidity absorbing property. The weak point of cotton clothing is its tendency to crease easily, which makes care of such garments more difficult. The cotton tendency to crease is due to the partially amorphous structure of cellulose. The structural alterations can quite easily occur in cotton. Many weak molecular bonds such as hydrogen or van der Waals forces which link together the long cellulose polymeric chains can alter because of the creasing. The primary cause of shrinkage of these cellulosic materials as they absorb moisture, it facilitates the internal polymer chain movements mainly in the amorphous zone by lubrication. It disturbs the internal hydrogen bonding between the polymeric chains. These moisture-laden cellulosic fibers is stressed. Internal polymer chains of amorphous areas are free to move to relieve that stress. As a result, they form shrinkage and creasing. To have easy care finish, there are numerous techniques. Formaldehyde contained resins. Urea formaldehyde resins. It is highly reactive. Within a few hours in the finishing bath, it has to be used. It has low stability to hydrolysis and low durability to laundering. Its high elastic resilience. Such kind of product is dimethoxymethylurea, shortly called as DMU. The next one is melamine formaldehyde resins. These are mostly 3 to 6 reactive N-methylol groups connected to one melamine rings. This leads to high cross-linking and easy care finish with good fastness property. It's provided by trio-2-hexamethylol melamine, shortly called as TMM and HMM, and by methyl esters. TMM is preferred for EC-care finish often over HMM as component of product mixtures to give you a better performance of FX. It's also used for permanent chins of cellulose. They produce firmer hands than HMM and are exclusively used as hand builders. Properties of melamine formaldehyde resins. They have better resistivity and stability to hydrolysis and better wash durability. Good dimensional stability and stiffness. The next one is glyoxal resins. It is DMDHEU, shortly called as. Its chemical composition is N, dimethylol 4,5 dihydroxyethylene urea. It is a chemical basis of 90% of EC-care finish and durable press finish products on the textile market. It is synthesized from urea, glyoxal and formaldehyde. DMDHEU is less reactive than DMU and TMM, but it is stable against DMU and TMM. Non-formaldehyde resins containing N-N-dimethyl 4,5 dihydroxyethylene, shortly termed as DME-DHEU. It doesn't contain formaldehyde. It is synthesized relatively expensive from N-N-dimethyl urea and glyoxal. It is similar to DMDHEU, can be modified by reactions with alcohols such as methanol, diethylene glycol or 1,6-hexanediol to ether derivatives. These are less reactive than DMDHEU because of their hydroxyl groups. Stronger catalysts or harsher reaction conditions are needed for successful cross-linking. The next comes to flame retardant finish. Flame retardants reduce the likelihood of fire starting by improving the resistance to ignition of potential fire sources. It plays an important role on textiles by providing safety and giving escape time from a potential fire hazards. When a fire does start, flame retardant reduces the flame spread and rate of fire development, providing the valuable extra time to the wearer in the early stages of conflagration to extinguish the fire or make an escape. A semi-permanent effect can be produced by treating with a mixture of ammonium bromide and brominated phosphoric acid esters. In case of polyester fabric, flame resistant can be subjected by treatment with an aqueous emulsion of xylene soluble 2,3 dibromopropyl phosphate using a conventional pad-dry cure techniques. Synthetic fibers usually melt on igniting by a flame. The molten mass is itself quite dangerous and a fire resistant treatment is essential for these synthetic materials. In case of cotton, the commercial chemicals used are proband and pyrovatex CP. The proband treatment to the cotton is a process of polymer formation by irreversible. Here the polymer is completely insoluble and is embedded in the body of cotton fiber. These phosphorus based compounds lower the decomposition temperature when the cotton fabric is fired. The next one is proband process. The molecules used here are sufficiently small. It's dried with nitrogen gas, causes small molecules to cross-link and form a polymer. Thus the polymer physically trapped and set in the core cotton fiber. Pyrovatex treatment. Here untreated cotton LOI value usually is 18%, whereas when pyrovatex treated cotton it's raised to 28%, mainly because of the phosphorus content. If the phosphorus content is reduced from 1.9 to 2%, the LOI value is increased to 30%, plus 2% increase compared to the 28%. Next comes to the antimicrobial finish. These finishes are of different types, namely bacteriostatic and bactericide. Bacteriostatic stops the bacterial growth, whereas in bactericide it destroys the bacteria. Antifungal agents are also classified similarly, fungistatic and fungicide. Antimicrobial finishes, according to the mechanism of their actions, they spread and act as a poison for the microorganisms in case of migrants, whereas non-migrants antimicrobial finishes, the products destroys the microorganisms when in contact with them. These type of finishes can be fixed chemically on the fibers using resins, chitosans, chitin. Chitosan, a derivative of chitin produced by deacetylation of chitin with concentrated sodium hydroxide. It's a widely used antimicrobial agent against various microorganisms. Some of the other antimicrobial finishing chemicals are bicarbonate, phenols and the derivatives, isothiazolones, metals, ammonium compounds, sometimes alcohols serve as an antibacterial agents for the finishing recipes. Some industrial chemicals are zeolite, inorganic compound of sodium aluminose, triclosan, it's a phenolic derivative, chitin, quaternary ammonium compounds. Antimicrobial treatments on the undergarments controls the growth of microbes on it. The characteristics of the antimicrobial chemicals are: finishing inhibits the growth of microbes on the surface of the fabric. It maintains the hygiene and freshness so that it stops the bad odor, eliminates the microbial staining, improves the life of the cotton fabric or man-made fabrics when it is applied. Hand value of the fabric is also improved. It eliminates the chances of disease transmission. In depth, the fungi and bacteria spores exist everywhere, even at hot and humid conditions. They rapidly multiply, feeding on the host. The antimicrobials try to attack the natural fibers, which causes the microbe to finishes applied to these causes the mildew and rotting damages. Natural fibers, importantly cotton, are more susceptible than the synthetics because their porous hydrophilic structure retains water, oxygen and nutrients, providing a perfect environment for the growth of bacteria. The enzymes that degrade cotton are cellulase and cellobiase, and these reduce strength and produce colored and foul smelling spots on the cotton fabric, even holes on the exposed fabric. Next is water and oil repellent finish. It is another functional finish widely used in the industries. The term waterproof refers to the finish that blocks interstices of the fabric by forming a hydrophobic film on its surface, thereby making the impermeability to air. The water repellent finish is permeable to air but not to water, as in case of waterproof finishes. Garments made from water repellent finishes are comfortable to wear. Water or stain repellent finishes can provide durable liquid repellency extremely against water and air without compromising the natural feel of cotton fabric. A proper chemical treatment and selection of fabric constructions provide a host of benefits to the wearer so that they stay clean longer, fast drying and protection from rains. These finishes have been developed in response to the consumer's need for easy care fabrics, which is described in the previous sessions. The water or stain repellent is usually a technical textile product subjected to various end uses such as outerwear, focuses on high degree of water repellency, and general wearing apparel such as casual pants wear more on stain resistance. A common water repellent chemical is fluorochemical repellents, usually used for the upholsteries, rugs and carpets textile materials. Some of the possible ways of bringing the water repellency to the fabric materials. Very ancient way to make a fabric water repellent is to coat with paraffin wax. Solvent solutions, molten coatings and wax emulsions are ways of applying wax to the fabrics. The most convenient products for finishing products is wax emulsions. Water repellent wax emulsions is emulsifying system not detract from the hydrophobic character of paraffin. Sometimes non-riveting emulsifiers deactivating the hydrophilic group after the fabric is impregnated with those kind of water repellent finishes. Paraffin wax melts and wicks into the fabric when fabric is heated. This causes most of the fibers to be covered with a thin layer of wax, especially those that are exposed to water, and the fabric will have excellent water repellent properties. The major advantage is its water repellency characteristics, while the disadvantage is its poor durability. Wax is easily abraded by mechanical action and it's dissolved in dry cleaning fluids such as laundering process. Fluorochemical repellents are unique in that they confer both oil and water repellency to the fabric media. The fluorochemicals have the ability to repel oils related to the lower surface energy formed, and it depends on the structure of the fluorocarbon segment, non-fluorinated segments of the molecule, orientation of the fluorocarbon tail and distribution amount of fluorocarbon on the fiber surface present on the fabric. Commercial fluorocarbon repellents are fluorine containing vinyl or acrylic polymers. To fiber surfaces, on fabric that orient airward and gives a reasonably close packed surface of CF2, CF3 groups of fluorocarbon chemicals. The next is soil release finish. It can increase the absorbency of a fabric. This finish allows the stains to leave the fabric faster, parallelly increase the wicking action for greater comfort to the wearer. It makes the fabric dry, cleanable with significant loss of soil release properties, and it maintains the brightness after the respective repeated laundering is a drawback. It permits better wettability for improved soil removal. It's done by hydrophilic finishing chemicals. It facilitates the soil release during washing. It prevents soil redeposition. Reduce the static charge by moisture maintenance on the fabric surface. Soil attraction during wear can be reduced by these hydrophilic based finishes. It's usually employed for the polyester fabrics since it is getting attracted to dirt or soil. Static charge electricity to hydrophilic textiles, making them susceptible to soil attraction. Redeposition of soil during washing is another drawback for the polyesters. The soils cannot be readily removed by hydrophobic materials such as polyester since their moisture regain is only 0.4, which affects in the laundering process. There are numerous chemical finish techniques. The easy removal of soil with ordinary laundering. Hydrophilic fibers and fabrics with resin finishes can also be able to develop soil repellent fabrics. Soil release finish increases the hydrophilicity of the material and increases the wettability. Parallelly, soil release finishes improves fabric drapability and comfort of the fabric. Next one is fragrance finish. Here micro encapsulation method is adapted for protecting various functional finishes on textiles. The capsules do not have affinity to fabrics. A binder should be used to fix the capsules for the purpose of finish durability. Conventional fixation is a thermal process in which a fabric is cured at 130 to 170 degrees Celsius for nearly 1 to 10 minutes to make the components of binder cross-link together across the fabric and tightly fix the capsules on the surface of the fabric. During curing, aroma inside the capsules can be lost through quick evaporation and swelling to escape or break the capsule. The loss from capsules can seriously reduce the amount of aroma on the fabric and loss in the durability. An aroma capsule finished cotton fabric treated by a thermal curing process can only bear washing cycles of 25. To avoid the thermal process, UV resin can be used to fix the capsules because the resin can be cured under UV light at low temperatures in fraction of seconds. Cotton fabric finished with selected aroma capsule with UV resin assistant can be cured under the optimal conditions, which can last for 50 washing cycles. Whiteness and stiffness of the finished fabrics are also considerably good in case of UV finish. The next one is hydrophilic finish. Hydrophilicity is a term mainly obtained from two concepts: hydro, water, philic, loving of a surface, which means the tendency of a substance to attract water. Cotton is a naturally hydrophilic material mainly due to the presence of alcohol group OH. These OH group form hydrogen bonds with the H bonds present in the water so that attraction of water molecules takes place. Usually silicones are inherently hydrophobic water repellents not used for these kind of finishes. Fabric is finished with silicones or any other softness for that matter, the hydrophilicity of fabric is decreased. The silicone has an organofunctional modification that allows the silicone itself to interact with water much in the same way as cellulose does. Silicones does not confer hydrophilicity to a fabric, which is mainly the hydrophobic purpose. The hydrophilicity of the fabric is obtained by the silicone softness improves at the higher dosage, which reduces the hydrophilicity of the fabric. Many softeners can be used to impart the hydrophilicity treatment to the hydrophobic fabric media. The next one is cool finish, conventionally and commercially called as snow cool. The garments finished with snow cool produces a cooling effect. The finish has two-fold effect. It reflects the light and transfers the moisture faster than normal from body to fabric and finally to the atmosphere. These finishing agents can be manufactured with or even without fragrance. When temperature rises, sweat produces is the natural metabolism of the human body. Though sweat, when evaporates, takes along with heat equivalent to heat of evaporation of water, thereby maintaining the temperature of the body to be neutral state. The snow cool finish uses the moisture management route, that is, it tries to enhance the natural phenomenon of sweat evaporation to make the body stable and cool. This finish absorbs and dissipates the sweat evenly throughout and thus gives a cool feeling to the wearer. The next important functional finish is ballistic protection. The ballistic protection through finishing can be obtained and it's mainly influenced by the moisture content, weaving oils, sizes, other lubricants. If the garments are made hydrophobic, 40% reduction in ballistic properties was reported when it is hydrophilic. The finishes mainly concentrates on the cohesion between the warp and weft garments for the ballistic so that it increases the ballistic protection. The next one is protection against the severe weather. It's another important functional finishes. Mainly here the breathable fabrics are produced through different methods. They are weaving a high density fabric, lamination technique, coating technique. The coating usually have two types. One is microporous coating and non-porous solid film. The conventionally used method is a lamination method for extreme weather applications. Here a water resistant breathable barrier is glued to the fabric. Sometimes adhesives is also breathable. The non-breathable adhesive is used to cover the entire area. The microporous films are nearly 1.7 million holes per square centimeter. Sometimes the polymeric films can be hydrophilic so that it absorbs water and deabsorbs as vapor. Apart from the lamination, coating here leads to the good stability and breathable fabric formation. It makes the fabric surface closer and closer so that it resists to the water. By formation of microporous structure on the fabric surface, it makes that the fabric is no hydrophilic in nature afterwards. The next one is UV protection. The protection offered by the UV cutting fabric is expressed in terms of UV protection factor, shortly called as UPF or SPF, sun protection factor. UPF of 40 for a garment means that wearer can stay 40 times longer in the sun before skin reddening occurs. The skin reddens in 15 minutes without UV cutting garments. The same level of redness would take 10 hours if UV resistant finish applied on the fabric. UPF is the ratio of time taken for the skin reddening with and without a protection. The characteristics of the UV protective fabrics are: they protect the human's underlying tissues from UV radiations. It protects against short wavelength radiations mainly from 100 to 400 nanometer. Non-yellowing. These finishing chemicals can be applied during the dyeing itself as a reductive process. Sometimes the conventional pad-rack cure technique can also be adapted for UV protective finishes. The commonly used finishing chemicals for UV protection in the textile fabric surface are TiO2, titanium dioxide, ZnO2, zinc oxide, where they are able to absorb the UV rays and reflects the visible and IR rays in the wavelength 280 to 400 nanometer. UV absorbed finished garments lessens the absorption percentage of UV rays. 10% UV on cotton fabric is reduced in this manner. Coming to the conclusion on the module, the functional finishes mainly for the technical textile products is not just about the surface finish on the substrate, but meeting with all functions in terms of performance and the user requirements. In the current scenario, the consumers demand more durability, more functionality than the ordinary clothing. These kind of functional finishes or specialty finishes represent the value creation in the area of technical textile area, so that the textile materials gets improved salability. Value addition on technical textiles can be in the form of multifunctional finishes like protective finishes, UV absorbers, antimicrobials, oil and water repellent finishes. Sometimes flame retardant finishes and waterproof finishes, thermal finishes are required as per the requirements. Apart from other finishes, aroma finishes, insect repellent finishes are also to be mentioned for the specialty finishes of the cotton fabrics and other fabric media. These functional finishes drives mainly for high quality need, more value added properties, discovery of new molecules. Nanotechnology, which is not discussed in this module, is another promising area and a growing field to produce the functional finishes. Exclusively deals with the science and technology at dimensions of roughly 100 to 100 nanometers. Nanotechnology can be used in engineering desired textile attributes through softness, durability, breathability, and mainly the advanced performance characteristics such as repellency, fire retardancy, etc. Innovative products will be able to open up these new markets, and the development of new products in technical textiles make a dent in the field of innovative technical textile market.